In this video, we're going to be discussing midsegments of a triangle. Here we define a midsegment as a line segment that connects two midpoints of two sides of a triangle. Instead of adjacent, it's just any two because any two sides of a triangle are considered adjacent. Draw the midsegment DF between sides AB and BC. Use appropriate tick marks. All right, so we're going to connect the midpoint of side AB. Use the tick marks to indicate that that is the middle. I could have done that more mathematically, but I'm just being a little bit informal here. And then we're going to find the midpoint of segment BC. And we're going to use the tick marks to show that that's the case. And we're going to connect them. All right. I adjusted that because of the midsegment theorem here. It says the midsegment of a triangle is half the length of the side it's parallel to. So I was adjusting that to try to make this parallel to this. And so we have points D and F as they told us to label. And DF would then be, well, let's answer these questions. It says, example 1, DF is parallel to which side of triangle ABC? Well, that would be side AC, as I already have marked. If AC is 15, then what is the measure of segment DF? DF would be half of the side it's parallel to. So if this is 15, then we would need to divide that into 2 to get the DF is 7.5. DF would be half of the 15. Let's go forward here. We are told that every triangle has 3 midsegments. Here we have triangle ABC once again, and the midsegments are already drawn. It says to answer the following questions and make the appropriate tick marks on the diagram. Segment DE is congruent to which other segments? All right, DE is right here. We know that F is the midpoint of segment BC. So these two would have to be the same length. And we know that DE is half the length of BC. So if DE is half the length of BC, and we know F is the middle, then wouldn't BF also be half of segment BC? So those would be congruent. So DE is congruent to, let's just list these segments, BF and FC. So these 3 are all the same. EF would be congruent to, well, BD is half of BA and EF is half of BA. So all of these 3 would be the same. So BD and DA. And now we might see a pattern here. DF then would be congruent to AE and EC. AE and EC. Okay, what can be concluded about each of the 4 triangles, smaller triangles that are created? So 1, 2, 3, 4 triangles there. Well, we notice that we have the green, the red, and the purple. Green, red, and purple. Green, red, and purple. Green, red, and purple on each of those. Well, we learned in the last chapter that if the sides are all congruent for triangles, then those triangles would be congruent. So let's answer that question by saying, all four triangles are congruent. How do you know? We can prove this using SSS, side-side-side congruence theorem. That's just something to pay attention to. Not anything that we're going to use a whole lot, but all right, let's talk about midsegments a little bit further. All right, let's try to apply this now. Example 7, MN and O are the midpoints of the sides of a triangle. Find MN. Well, let's first make some markings here. Find MN. Well, we know MN is going to be half of that one. Well, if that's 5, this would be 5. Or in other words, we know these are congruent, as we just learned. So MN would have a measure of 5. XY. XY is going to be related to this midsegment, ON. ON is 4, which means, each of those would be 4. So XY would have a total of 8. And then it says to find the perimeter of this triangle XYZ. Well, we know that that's 8. We know that this is 10. And we need to find these other two here. If that's 3, this would be 3, and this would be 3. So this side would actually be a total of 6. So the perimeter is 6 plus 8 plus 10, and you'd get 24 units. Here we are asked to find the value of x and the length of segment AB. They didn't tell us this, but we're going to assume that this is a midsegment. It's important, otherwise we would not be able to solve this problem. All right, so we know that the midsegment should have a relationship with the side that it's parallel to. And that means that the midsegment, that AB is, and this is kind of tricky to write when you're first starting, but AB is half of what XZ is. So we can fill that in by saying AB is actually 3x minus 1, 1/2 of 34. And some of you may have been just thinking, well, half of 34 is 17, and so I know that AB needs to be equal to 17, and AB is 3x minus 1, so 3x minus 1 needs to be equal to 17. That's fine. You simplify here, and you would get the 17 anyway. But if we add the 1, we'll get 3x equals 18, and divide by 3 to find that x is 6. They said find the length of AB. Well, if this is 34, and we know that AB has to be half of that, then we already know that AB is going to be 17, which is half of 34. One other way to solve this would be saying that, 2 of the length of AB would be equivalent to XZ. So if you're not liking that fraction, you can double the mid-segment and set it equal to the side that it's parallel to. So this time you would get 2 times 3x minus 1 equals 34. And then you distribute 6x minus 2, 34. You add 6x equals 36. And once again, x equals 6. So whichever way. And that concludes our first lesson